So my talk will be about building analytic systems with Elixir. So probably there will be not so much Elixir as it should be. But yeah, I'll start. A little bit about me. So my name is Dmitry. My GitHub is Life Forever X. I'm using Elixir since 2012 or something like this. Have contributed to Elixir. Currently, I'm a lead engineer at Appian working on process mining, which is analytic system in this sense. And before I worked on the expert systems, distributed systems, and telecommunications. So yeah, let's start with some definitions because I'm not sure how many people from you have used or built analytic systems. So analytic software is a software which is doing systematic computational analysis of data or statistics. It's used for discovery, interpretation, and communication of meaningful patterns in data. So it entails applying data patterns toward effective decision making. Some characteristic of analytic systems. With most systems which are built for Elixir, except of course NERFs and so on, you have the number of users which you have is a few one. So that means in a case like WhatsApp, you do not care much about massive concurrency, about a lot of processes which you can start. So most cases which you have a few users, maybe even just one user or like 10, 15 or depends of, but what these users try to do with your system is complex. It has like massive complex data. It has complex queries which you need to run on this data, and even one user might use a cluster of machines to do this. So, and some typical parts of such systems, without taking in account like distributions and so on, you have different sources which you want to analyze. You have very often some ETL system which needs to process this data, pre-process, to make it in some sense that your system can effectively use it. So it's it's stored in a different storage than your kind of a production data. So, and you of course have user. So yeah, what is ETL? ETL is a three-phase process for data preparation, which is actually consists of extracting data from, it can be different sources, it can be, then it's a transformation of this data to give more meaning for your system, and then kind of loading data to the system in some storage. Let's speak a little bit about storages. I will start from, let's say, who knows what is a columnar databases? A few one. Okay, great. So that's why I have prepared a short introduction. If we just like take a simple table, for example, where we save some information. Information right now is not important, but just we have any table. How it will be saved if you use some classical SQL databases. So it will be, of course, it's more complexer, but more or less what you will have some ID where you save in a row where you have like all your data just more or less in one line. So, and what's different if you use a column database, or like columnar storage format? What you have you actually do not save the whole rows together. You just save every column which you have separately from everything else. As you can see on example, for example, the first name and last name, they are saved completely separately. So, and this is the whole idea of the column-oriented database management systems. So it stores data tables by column rather than by rows. Which advantages it can have? It has a faster querying of subset of columns. So that means if you do not need the whole data, which can be after you have exported a lot of data from different systems, you can have like 20, 30 columns. And for your what you want to analyze, you need only like a few one. For example, some timestamps and like some metrics. What you can do is by faster querying, you can just load a subset of columns. You don't load the whole row together in memory for doing this. So additionally, it gives a faster sorting, grouping, and any range queries because first, this is kind of, you have for all columns like an index in this sense. So that means you can take any column, and if you need to sort or group, you can do this by column and then only take other data from other columns for this. So, and it has a better compression. Especially very naive if some data, for example, city or something like this, is just repeated. So you save for a user city, and then instead of having multiple rows with a city, what you can do, you can specify a range. For example, like city Berlin from 100 till 350, and you know that it's like the whole range is in the same city. So this is how in the column storage, for example, can be applied compression. So by because values are not, if values are not unique, it's much easier to apply compression on such columns. So. Yeah, and of course it has disadvantages in comparison to the traditional databases. Slow update of existing data, especially if you just want to update one row, then you need to kind of find it, or like insert, especially insert somewhere in the middle of your data. You need to find like update your rows separately. Except the one exception to this, it's a faster insertion of a new data because you just can attach the new data to columns. So, and the second thing which I wanted to introduce, does anybody knows what is SSE or SIMD, and have anybody worked with this? One, two, nice, okay. Yeah, the introduction will be shorter for this. So SSE is a streaming SIMD extension technology, and it's actually, I think it's introduced by Intel initially, but all modern processors support this. It's processor support for kind of vector operations, which means like SIMD is a single instruction, multiple data. So that means instead of, for example, if you do addition, instead of saying, okay, do addition for 1 plus 2 and then repeat this addition for other data. You say, okay, do the addition for this array, for example, with 1 digit or like with this array, and you get as a result from this processor instruction the new array back. So it will be, I will explain later why I have introduced everything this. So let's start with kind of abstract building ETL with Elixir. So how it might look like. And let's start with an export, the first thing. So, and it's actually based on experience. So, and for a lot of data science use very often something like simple like CSV, or it's might look like simple. It's actually more or less easy for users, but not so easy for machines. So, and to analyze with, like to read and CSV files is a natural choice. Might be the Nimble CSV, which is actually a really great library for doing this. But then let's, because actually from data scientists, how they use it, it has a different formats of CSV, not really standardized as it should be. So, and it brings that you can have a very different delimiter or like separator in your file. So, but how this looks like with a Nimble CSV, it's actually defines a module for this, for one separator, for one separator, and it defines one module for this, and it does this for a good reason. It does performance optimization, which are not possible with a dynamic kind of a configuration for this. So at least not in Elixir. I did not found again, but I saw that somebody from Elixir community has tried to implement Nimble CSV as completely dynamic, and there were some benchmarks and some operations were twice or 3 times slower. So if you would try to use this, so most probably you will need to define the code dynamically, but it's okay in most cases because the amount of delimiters which are used in Wild limited. So I don't think that somebody will use the whole UTF-8 chars to define delimiters. So that's why it's either to find out all delimiters, or just if you see a new one, you can implement something like a gen server, which if it's not exists, then you can evaluate your code and use this. So, but for other reasons, you can use for this Rustler with Elixir. It's first of what Rust gives to Elixir systems for this, whenever you need to copy, upload, or like process a lot of data, it's 10 times or sometimes more faster what you can get from by using Rust. And CSV libraries is configurable in runtime there. So you just take your CSV reader builder and puts any delimiter and a lot of other configurations which you need. So for use Rustler, it's you use like a NIF interface of Erlang, and there is one hint I checked because before, whenever there were no duty schedulers, there was in the documentation of Erlang says your NIF should not take no more than 1 millisecond. So because otherwise it will screw schedulers or like lagging behind of on the schedulers of Erlang themselves. So, and for people who don't know, this is, I think it's good to know that it's not anymore. It's even not so in the documentation. You can have a long-running processes which are implemented in C or Rust. Rust is better because of the safety. So, and it's enabled pretty easy with some, just you need to define a flag. I did not found this in the Rustler documentation, but this is how you can define this by schedule and just specify if it should use DOT IO or DOT CPU. So, to say a little bit about using Elixir with Rust. So, Elixir is great for everything around, where you need like API, web communication, concurrency, control, progress information. That means what you can easily do, for example, implement an Elixir like a progress reports whenever you just send from Rust messages how much data were processed. So, and additionally, Elixir is still very good at fast prototyping. Even if you need export from some complex data source, you probably will be much faster. First implement with Elixir, get some data, experiment with this until you implement this in Rust, which then is kind of optimized for optimized for big chunk of data. Yeah. Let's switch to the second step by implementing one part of ETL process. It's a transformation. Depends on how it's implemented kind of in your system. If it's like hard-coded, you know all your formats, or if you want to to give the system to other users, where they can input any data source they want, but they need then to bring it to the defined format for the analytics. So, and transformation, which actually means, okay, you need to filter data which you don't need, like incomplete data. You need maybe join some columns, replace some values, simplify values, type values, because you can have like timestamps, for example, in a very wild format, some RFC format. So you need to kind of be able to parse different kind of timestamps and then make joins for this data. So, and in the end, what you will have, this is like some chain of transformation which you want to apply on the data before it becomes the format which you will need for your analytic system. So, in Elixir, there are, I would say, at least known to me, like 3 more or less transformation possibilities. How to define this? You can have like JSON structure or like any other format. For example, for the API, where you have a front end which says, okay, how to transform, and you can specify steps here. And then you need a front end on something and something like this. Another one is if you are working very close with data scientists, and then you can provide a DSL for Elixir. Elixir is great. One of the reasons is that it's very easy to have something like a custom domain language. So, but it has security concerns if because actually still you need to load fully functional module which is written out by developers to your system, and if it's not a trusted people, so you cannot just like give this something to, for example, in a cloud. You have multiple users which just registers and can upload any Elixir module with your DSL. You have like some security concerns. So except you are doing a very hardcore static analysis of what they're doing with your DSL, you can have all these problems. And then the third option is to create some custom language using Lex, Yak, or for example. So for transformation, almost one of the goals for the transformation is produce one query and give this query to your database to optimize execution. Because as much actions you can give to optimize for the database, less actions you need to optimize by yourself. Is not always possible, just to say in advance. That's why part of transform step involves building and manipulating queries. Something like ecto query is an example. Actually, on one of the systems we have thought, okay, if we could reuse ecto query and just like build an ecto query and then let ecto to give it to the database. So then we would not need any, we would not need to produce any SQL queries and so on by ourselves, which would probably simplify this task. But it's not with ecto if your systems involves any unknown sources. That means you cannot specify directly inside of Elixir in advance which columns you would use. And for example, you need kind of dynamic columns. This is something what currently in ecto does not support it. And to my knowledge, it's more or less one of the only existing limitations. You need to know columns in advance. But if you want to allow a system like to connect different sources which you do not know in advance, you always will have like dynamic table names, dynamic columns, which you need somewhere serialized to string. So, and more or less, you will have inspired by ecto something like your own query structure. So maybe instead of this, you could bypass the step, but databases are different. Let's look into one abstract query, or like more or less complex but abstract query where you want to have some select from, you want to prepare a little bit of data before and do some joins because you have data from multiple sources. But this query won't work on all, or it might be just slow. So because, for example, multiple joins in one go might be costly, or even database would not do this so efficiently that it can't execute this. But then what you can do is you can rewrite a query to just like do one join at a time, or like two joins, or like reorder joins, and so on. If you look into the initial query, or like how you have rewritten, one funny fact is about MariaDB, because like MariaDB supports column store, so but it does not support sub queries. That means instead of using sub queries, you are forced to use CTS. To be able to kind of execute a complex query on MariaDB. And it has a limit to 64 CTS in one level. So pretty often some queries, some complex queries can actually exhibit this limit. As we have talked about columnar databases, I would give a small introduction which columnar databases there. Of course, it's always good to reuse your main database, for example, Postgres or MariaDB, and they have actually extensions. Postgres has a Citus extension. MariaDB has a column store. Column store in MariaDB is a little bit more advanced. Citus is less documented, but yeah. MariaDB has other problems. For example, it does not support recursive queries, which is, I would say, a common task to prepare data. Clickhouse is one of good and open source databases, but there are others, which is, for example, a DuckDB, which is built in to be embedded database. So that means you do not have a server, but you want that your data are co-located on the same in the same application, or there are like some databases which are like vertical, which is completely in cloud, and you need to pay for this, and hope they are doing optimized product. Yeah, and there are additionally kind of columnar databases libraries, which are a little bit more low level. And then I would go into the cases in which cases you might need to consider to go a little bit more low level in the columnar database technologies. So, and for this, I have a picture how your analytic system will look like in the front end. You have like a user, and he looks into the data. It has some aggregations, different aggregations for this, and he might go and introspect this data, and he wants that it runs smooth interactively. So that means whenever he just like selects any new filter, it's re-renders within without going to take a coffee break, because terabytes of like gigabytes of data which he has start to recalculating what he's doing. Yeah. And in which cases you want to heavily, like in which cases you would look into these technologies, like if you want to heavily exploit SIMD operations. That means use vector programming, and you want to optimize data layout, which is might be needed for this analytic. So for the vector programming, it's as we have seen for the SIMD processor, it's, for example, in KDB Plus, the whole language where you can. This is like arrays. They do not like classical arrays, but you can, for example, if you do array plus array, it's actually what it does, produces a SIMD operation where every element of array is added to the every element of array. But it goes to the extent if you, for example, have your defined function and executes on some array, it will be executed on every element of array. So that means you actually can optimize in a sense that you are working with arrays, and it's called vector programming. There are like APL languages which are invented by mathematicians. Almost 1% of developers uses this one, but I just wanted to know that know that this exists. So, and one kind of a state of the art for this is a Polars, is a data frame interface on top of OLAP query engine, implemented in Rust using Apache Arrow columnar format. And one note for this Apache Arrow columnar format, that this format is used by multiple technologies. For example, I have said earlier about DuckDB. You can use Polars and DuckDB on the same source. With DuckDB, you can execute SQL queries, and with Polars, for example, do some more advanced calculations. So, and last topic is about optimization data layout on example. What does it mean actually? And it's not possible in SQL. Let's take a simple query as an example, how it can look like. So, for example, we have some processes and we want to know how long they take just by calculating some process duration, which we can archive with a pretty simple query. Let's select like max timestamp, min timestamp, and define this as a like minus as a process duration of it. So from a process, we might have like multiple events there which define a process. So if we look into the example using Polars and Python initially, it will look like almost the same, where we do the group by and do some aggregation. So it's but less familiar. It has less familiar syntax. And sorry, I have done this last example in Python instead of Elixir, but exactly this example should be possible to do in Elixir, but a little bit more verbose as it's right now in the Python. So yeah, why you would optimize could optimize your data layout if your system may have like query patterns which occurs very often. So that means you just like have some filters or like a lot of calculations which have the same pattern. And not always you can pre-compute efficiently these patterns. And tools like KDB plus Polars, which going in low level, allows this. And it's actually antipode for the SQL, because SQL wants to abstract your storage away. And this is something where Polars and KDB plus gives you access to how your storage looks like. And how this optimized query might look like to do the same thing, but with kind of without group by. So group by is an operation where you need first to sort the whole data to get your groups and to do the calculations, which will be like log n for doing this. But this query will work actually within almost linear scan of your data. And to understand how and why, we can try to understand what it does. First of all, one pre-requirement is you lay out data where you have your processes already sorted. So that means your processes, instead of grouping of data, your processes are already sorted by ID, and that what you need to do then is to produce kind of a mask where you can check by diff and produce a mask whenever the process ID changes, mark it's your start of a new process. So that means without a grouping data, you can already with a mask set, okay, here is my process ends. So by just like linearly going and doing a diff one. What happens next? You can do shift and fill operation, which actually does, okay, if we know where our process ends, what we can do, we can take the column, one value before, and fill it's with a true, and say, okay, everything what's before in our mask, everything what was before one is something what is the end of a process. So, and this with then you have like a two mask where you have said, okay, this is my start of a process, this is like end of my process, and then what you do, and then what you do in the end, you take values from these two masks in one linear scan, and says, okay, I would just subtract the end of my process from start of my process. and then you get a duration without grouping by just having kind of layout the storage for your data accesses. And this is what allows, that's what allows like technologies which are kind of done for the vector processing to do this. One note to say that Explorer actually uses polars. Underneath, it has a shift and fill missing. It doesn't have shift and fill, but it has some functions already, which probably are sufficient to use like this technology, like this. But the API from Explorer is not so advanced currently as Python 1. So, and to add some concluding observations, Elixir is great to glue everything together. It's for like a web concurrency and introspection of your system. And in comparison with the Python, I think some other speakers have already said, you do not have like separate services for Python, because even for Python, you probably, if you do the distribution, it will be pretty not nice to deal with a system like this. So it's easy to add Rust for heavy data optimized heavy data processing, especially with dirty nifs. And Explorer already utilizes one of the fastest libraries under the hood, which is Polars. But current core API is limited. There are some things, for example, you can't use regexes on a data with Explorer, which limiting your cleanup. Thanks for listening.